So today we're going to look at lesson 7-6. We are going to use our skills at compressing and our skills with logarithms to solve equations that have logs in them. And there are two types of equations that we're going to look at today. The first type is if you have a log equaling a log, and then the second type is going to be a log equaling a number. So let me make this a little bigger. So this is the process that we're going to use right here to solve any equation that has more than one log in it. So for instance, if you look down here, we have a log equaling a log. It's kind of the same concept as when we had a power equaling a power, but this time we have a log equals a log. So you're going to use this one-to-one property. It makes logic reasoning sense that if you have a log with the same base equaling a log with the same base, that their arguments would be equal. So what you're going to do is drop the logs. Once you have a single log equaling a single log, you'll drop the logs and just set their arguments equal to each other. And then you'll solve, and you have to check for extraneous solutions. And the reason why you have to check for extraneous solutions is because, remember, the argument itself here and here cannot have a negative or a zero value. If it does, you can't take the log of it because it's undefined. So let's go ahead, and I'm going to go through the evens with you. If you want to see the odd answers, you want to work the odd answers, you can go onto my website and look those up. All right, so for number 2, we've got a single log and a single log. They have the same base, so we can just set these arguments equal to each other. So 1 minus 4n is equal to 2n plus 43. And so then you just use your algebra skills. You want to get your variables together on one side. That should be your focus first. And then you're going to solve for your variable term or isolate that. And then divide by 6, and n is equal to -7. So there's nothing that says you can't have a negative value, but you just can't have that value create a negative situation here. So if you plug -7 in here, you're going to get -4 times -7 is 28, plus 1 is 29. So that does not create a negative or a zero value. So far, -7 is a good answer. And up here, -7 times 2 is -14. When you add it to 43, you will get a positive value. So we can keep this as a good solution. All right, the difference between question 2 and question 4 is now all of a sudden I have 2 logs on this side and 1 log over here. You cannot drop the logs until you have 1 log equals 1 log. So we are going to have to compress this using what we learned 2 lessons ago. So remember, if we want to compress those into 1 log, and this happens to be a base of 10, because these are being added, we can multiply them. So I'm going to multiply them and put the 4 in front of the y plus 5. And now that I have a log equals a log, I can drop the logs and just set the arguments equal to each other. And now all you have to do is solve. So distribute. And solve. And then you have to check your solution. So plug 13 in up here. 13 plus 5 creates a positive value. So that is a good solution. So then what I would like you to do is try 6 on your own. So go ahead and pause the video and do number 6 and then check your answer. So because we have 2 logs on this side, we're going to have to compress. And because we are using subtraction, we're going to have to compress by using division. So we're going to divide 68 by 4. then simplify. 68 divided by 4 is 17. And now that I have a log equals a log, I can set the arguments equal to each other. And from here, the algebraic solution is pretty simple. And even though your answer is positive, you still have to check to see if it's going to create a negative. So I don't have any variables here, but over here, if I multiply 3n by 2 and add an 11, you get a positive value. So n equals 2 is a good solution. So then you try number 8. The only thing with number 8 that you have to be aware of first is that you have this 2 in front of the log. You have to loop it up to the 6 as an exponent first before you can compress these into one log. So we're not going to touch this. And then that 2 loops up here to become an exponent. And then 6 squared is actually 36. So I'm just going to replace 6 squared with 36. And then to compress these, we're going to use division. And then simplify. And now that you have a log equaling a log, you can set the arguments equal to each other and solve. And so you get P is equal to 7. And then if you check, 2 times 7 is 14, minus 5 is 9. So that is a positive value. So this is a good solution. All right, let's look at the back page. All right, so the only difference with these, let's look at not 9, let's look at 10. So 9 and 10 are going to require some factoring. So let's look at 10. 10, you're still going to have to compress these into one log by multiplication. So you get log of 2k squared. I just multiplied the 2 and the k squared equals log of k squared plus 16. So now that you have a log equals a log, you can set the arguments equal to each other. And then you want to solve for k. Well, you have 2k squareds. So you have a couple of options. You can either move the k squared over here, or you can just move everything over to this side and set equal to 0. So I'm going to show you 2 different ways that you could solve it. So this will be way 1. So with way 1, I'm going to subtract the k squared from both sides. So if I do a minus k squared and a minus k squared, I would end up with 2k squared minus a k squared is 1k squared equals your 16. Then to solve for k squared, you have to take the square root of both sides. But remember, because k is squared, it's got a degree of 2, which means we have 2 answers. So you cannot forget to do plus or minus when you do your square root here. And so k would equal positive or negative 4. So way 2 would involve factoring. So way 2, you would want to get one side equal to 0. So not only would we move the k squared over, but we would subtract 16 as well. So we would subtract 16 and subtract 16. that would leave us with k squared minus 16 and equals a 0 because everything has gone on the right. So if you recall, isn't this the difference of two squares? So the difference of two squares factors as k plus 4 and k minus 4. And then if you set k plus 4 equal to 0 and k minus 4 equal to 0, you will get k equaling negative 4 and positive 4. So no matter which way we approach it, you're going to get the same answer. So if you plug negative 4 in here and square it, you're going to get a positive 16. So even though the 4 is negative, because we square it in the original problem, it turns out to be positive in the argument. Same thing's going to happen here. We're going to get a positive value. So both of these are acceptable answers. All right, so what's going to happen if we have just a log equaling a number? So I'm going to back into this a little bit. So we just have a log equaling a number. Our process is going to be these three steps here. So you're going to condense, so you're going to get any logs that are more than one log together, so you're going to condense those, and you're going to isolate them on one side. That means you want to get the one log on one side by itself. Then once you do that, you have everything else on the other side. You're going to have a number on that other side. Just put your equation into exponential form, and then you can solve. And you still have to check for extraneous solutions. So let's go ahead and look at 12. Move this over here, make it bigger. Whoops, there we go. Okay, so in this particular situation, we only have one term that has a log, and it's this one. We don't have more than one term with a log. So we want to get this log by itself on one side. So I want to isolate this. That means I need to get rid of this minus 7. So to get rid of a minus 7, we want to add 7 to both sides. So I end up with log base 3 of 4x plus 8 equals positive 4. And so we've done this before. In a previous one, we want to put this into exponential form. So this is going to be the base of our exponent, a 3. And then remember, we switch these two around. So I'm going to get 3 to the 4th is equal to 4x plus 8. And 3 to the 4th is 81. And then I just solve for x. And then divide by 4. Don't give me the decimal answer. I want the fully reduced simplified fraction answer. And so 73 over 4 is the correct answer. And of course you have to check it. 73 over 4, if you put up here, 73 over 4 times 4 is 73 plus 8 is going to give you a positive value. So it is acceptable as an answer. All right, we have two more left, so 14. So on 14, before you can do what we just did on 12, you have to compress these two. And before you compress these two, you're going to need to loop the 2 up here as an exponent. Then you can compress these. Since it's subtraction, we would use division. So you would have log base 10, and then remember that x is squared because we looped the 2, divided by 4 is equal to 2. Then because I know this is base 10 because it's missing, to put it into exponential form, I've got 10, and then we're switching these two to the second is equal to x squared over 4. Well, since you have a fraction here and not a fraction here, I would just turn the whole thing into a proportion. 10 squared is 100, and I would put that over 1 equals the x squared over 4. And remember, to solve a proportion, don't you cross multiply and solve? So 1 times x squared is x squared. 100 times 4 is 400. You can take the square root of both sides. Don't forget to plus minus. And you get x is equal to positive or negative 20. Then you've got to check. Actually, I think I will write this out separately because I know for a fact one of them is not going to work. So positive or negative 20. So let's try the negative first because they tend to be the ones that get thrown out. If I put a negative 20 in here into the original, I know we loop this up to square it, but we have to look at the original. It creates a negative in the argument of the log, and that is undefined. And in fact, you can try to take the log of negative 20 and it will give you an error. So we have to throw it out. So our only good answer is x equals 20. So for the final answer, I want you to try this one on your own. Pause the video and then recheck your work. All right, so we're going to compress these two. Because of addition, we're going to use multiplication. So log of x times x minus 3 is equal to 1. The base of this log is 10. So to put it into exponential form, the base of my power is 10. And I'm going to switch these two. So I get 10 to the first is equal to x times x minus 3. To solve, I'm going to need to distribute. So I get 10 equals x squared minus 3x. Since I have an x squared and an x term, I need to move the 10 over here and set one side equal to 0. So subtract 10 to both sides. 0 equals x squared minus 3x minus 10. X squared becomes x and x. And then the factors of 10 that subtract to give you 3 are 2 and 5. The 5 is bigger, so it carries the sign of the middle term, and the 2 is going to have to be positive. If you set these equal to 0, you will get x is equal to negative 2 and positive 5, and then you have to check. Take negative 2, if you plug it in here, you get a negative, and here you would get a negative value. So we are going to have to throw the negative 2 out. And then if you plug 5 in here, you get a positive value and a positive value. So 5 is a good solution. So please try the rest of your problems and your homework and ask me if you have any questions.